Hello, this is the course of data engineering, and in this course, I would like to discuss how to deal with missing values. So the overview of this course will be this one. First, I would like to discuss about the definitions of the missing values, and I would like to discuss about the approaches for handling the missing values. So for example, simple approaches and deletion approaches and imputation methods, also the multiple imputations. So the definition, what is the definition of missing values? What is missing values actually? If you are dealing with the data analytics, if you're dealing with the data engineering, okay, so you will have this kind of missing values. And we call the missing value as a value that was not introduced. So the value is not available, or value was lost in recording process. So yeah, basically no value, okay? No value in the data. There are many reasons. Okay? There are many reasons for the missing values, like for example, manual data entry procedures. So when you do the entry data manually, okay, then there will be a problem because human can do some errors, and maybe the person missed to enter the data, or some equipment errors that may happen, and also incorrect measurement that can be also the reason for the missing value. Simple way to handle the missing value, or I can say MV, okay, so I call it this MV, is to discard the data. Yeah, this is very simple. Okay? Discard means you delete. Yeah. You can delete the data and then finish. But it is practical if the MV is relatively small. Okay? If your MV or your missing value is small or not so many, then okay, you can just delete it. And the analysis of complete instances will not lead to serious bias during the inference. So for example, if you delete the data and there is no bias, there is no serious bias when you inference. So inference means you want to check the data and you want to analyze the data, the correlation of the data, and you want to know the covariance of the data and etc. Yeah, if there is no serious bias, then yeah, no problem. But in many cases, yeah, there will be some issues with that one. MV or missing values make performing data analysis difficult. Yeah, this is very serious issue in the data engineering. And the presence of MV can pose serious problems. For example, if you handle the MV inappropriate, yeah, it could introduce the bias, and it can result misleading conclusion, and also it can limit the generalizability of the research finding. So this kind of missing values you need to handle with very careful. And other type of problems with the missing values, for example, if you miss to handle the MV, there will be loss of efficiency, and there will be complications in handling and analyzing data. And of course, yeah, bias, okay? Because the bias happens between the missing value and the complete data. Okay? So this kind of issue make the missing value is tough, okay? Because when we are dealing with the missing values, yeah, we need to be very, very precise to know what kind of the approaches to handle missing value. So here we will discuss the approaches, the basic approaches. There are three different basic approaches to handle the missing value. As I mentioned to you, the first is to discard the data or instances with missing value. So this is the very basic one. The second basic one is to use the maximum likelihood procedures. So we want to estimate the parameter of a model for a complete portion. Let's say I have the data and then I can create a model, and I would like to use that model to predict, or I want to use that data to understand the missing values. So we can use the imputation by means of sampling. So this is the basic one, yeah. Or we can do imputation. Yeah. So the imputation means we can fill the missing value with some estimated values. So this estimated value can be anything. For example, you can use the mean, or you can use the median, or any kind of estimated values that we will learn in this class. So before we deal with the approaches, we need to understand the assumptions and how the missing data will do. So I call it, this is the missing data mechanism. It is important to categorize the mechanism which lead to the introduction of MV. The assumption we make about the missingness mechanism can affect which treatment method could be correctly applied, if any. So if I know that this is the missing type 1, then I can think what is the best approach for this kind of missing type 1. If the missingness is type 2, then yeah, we can also try to figure out how to handle the missingness type 2, and so on. Okay. When we are dealing with this missing data, I can have 3 different assumption and mechanism. So this is the common definition in the missing data. So first is missing completely at random. So we call this is MCAR. The missingness of a value is independent of attributes, and we can fill in values based on the attribute. Analysis may be unbiased overall. So missing completely at random. We can have like this one. For example, I have the data. Let's say this is like the questionnaire. Okay. I have the person 1, person 2, person 3, person 4, person 5, person 6, for example, like this one. Okay. And when we have this data, I know already that who is the person 1, who is the person 2, who is the person 3, who is the person 4, and so on. And when I ask the person 1, okay, he respond and he give like the information, for example, the age, and then the gender, and then let's say income, okay, and then let's say I don't know, job, okay, maybe the position, okay, and then let's say the address, and let's say the number of children, okay, and so on. Okay, now when we have the missing completely at random, what does it mean? Yeah, I can say it is related with the one instance. Let's say when we give the questionnaire to P5, the person number 5, he didn't reply at all. Okay, so there is no data in the person 5. So it is completely at random. And we can fill in the values. Let's say because we have only 5, we have only 6 persons, so we need to have this data. And I know, okay, the person 5 is, for example, he's a friend of mine, so I know about his age, I know about his sex, okay, but I don't know about the income. but I can try to figure out some values about his income and so on. So if you know already about this one, then yeah, the analysis will not be unbiased overall. Okay. The second type of the missing value is missing at random. The missing is related to other variables and fill in values based on other values and almost always produce a bias in the analysis. For example, when you have your data, let's say if I know that the he is a male, okay, yeah, he doesn't want to explain about his income. Okay, so maybe this one is not available. Yeah, so there is random value. Okay, it is random. Maybe another male, yeah, he is okay to explain the salary. For example, the income is $2,000 US. Yeah. So in one case, yeah, the person one, he didn't want to say about his income, but the person three, he is okay to mention the income. So we call this is missing at random. It's random because someone may not want to give the information about income, but another person may be okay to share the information about the income. And if you want to fill in these values, if you want to fill in with the average or maybe the median, it can produce a bias. So there will be a bias. And the other information is about missing not random. So missing not random is the missingness is related to the unobserved measurements. So it can be informative or non-ignorable missingness. So for example, maybe I can say like, if I have the information about the age, okay, I have the information, this one is 25, okay, male and not available, and maybe I have like the 30, and yeah, I have the information about male and the income is $2,000 US, for example. Okay, so we have no information about children. Okay? We have no information about children. Okay? So this is we don't have any we don't have any observation on the number of children, so we do not have any clue whether with the sex, with the income, with the age, is there any correlation with the number of children. So maybe you can say like, if the income is high, the number of children will be also high, because when you have family, of course you need to think whether your income is suitable to have a living with your family or not, right? So that kind of the missing information here, we don't have any observation, but it's missing, and it is non-ignorable maybe, or it is uninformative, because when you have a greater number of children, it means you have more living costs. So that kind of things, if there is no information of this one, we can say this is missing not random. Maybe the person they forgot to fill in this value, okay, because some of this value are more important than the number of children. Or there is not possible to know the situation from the data. So if you do not know the situation from the data, then it can also be a missing, one of the missing value, one of the missing type for this kind of data engineering. So let's say, yeah, we can arrange something. We can arrange the data with this kind of tabular format, and yeah, we know that in the tabular format, the row indicates the instances, okay? And then the column indicates the attributes. So the missing values, yeah, you can see like this question mark. Okay? When you have this question mark, it means yeah, those missing value. And how can you handle this one? Let's say yeah, you need to handle only this part. Okay? And in this instance, you have two missing values. In this instance, you have two missing values. In this instance, you have two missing values. So yeah, this kind of missing value, when you appear with this n number of data, okay, so if you need to delete this one, of course, yeah, it will make your data loss. Okay, so you don't have a lot of data for your analysis. But if you don't delete it, it will ruin your analysis. So which one is better? That's why, yeah, we need to handle this one with a very precise way. So we can have like this formula to indicate the assumption and the missing data mechanism. First, yeah, we can have like the x. Okay? X, we have two kind of values. The first value is the observation, and the other value is the missing. Okay? We call x OBS is the observation, the observed part of x, and we denote the missing part as x miss. So let's suppose that we dispose of a matrix P of the same size of x. Okay? And P values are 0 or 1 when x elements are observed and missing respectively. So if it is not missing, then we can put 0, and if it is missing, we put it as 1. So we can do that one to indicate the x properly. And the MAR, okay, we can make a kind of formula to understand this MAR, MCAR, and NMAR. In the case of MAR, missing at random, the distribution of P should be related to X. Okay. So P is the number, okay, the number whether it is 0 or 1, it should be related to X. X is the data that you have, and to some unknown parameter. Okay? So this unknown parameter is, yeah, it depends on the distribution, for example, or yeah, you have another kind of parameter in your data. So we dispose a probability model for P described by this one. The probability of P given X. X is any distribution. Okay, so we have the X before. We have the X is the observation and the missing. Okay, and we have the information about the parameter. Now, when we have the missing at random, okay, the assumptions in this context, it means that the distribution does not depend on the missing value. So, for example, this one, we have the probability of the P. Okay, so the probability of P given by the observation, given by the missing value, and given by the parameter, it will be the same with the probability of P given by the observation and the parameter. So it means the missing value does not affect the probability of the probability model of 4P. So without the missing value and with the missing value, the probability of the model B is does not any dependency with the missing values. That's what the meaning by missing at random. MAR does not suggest that the missing data values constitute just another possible sample from the probability distribution. Okay. So if you have some other kind of distribution, then it can be the missing completely at random. So the missing completely at random is it is a special case of MAR. Okay, in which the distribution of an example having a missing value for an attribute does not depend on either the observed or the unobserved data. Okay, so if the previous probability for the model B, if you have the model B, it depends on the X observation and the X missing value and the parameter. So it means, here is the MCAR. It does not depend on the observation and the missing value. It means, as I mentioned to you, like when you have the data like this one, so one row is missing. Okay. So it will not affect to the other observation. It doesn't affect with the missing value itself. Okay. So this is the special case of the MAR. Under MCAR, the analysis of only those units with complete data give valid inferences. So although there will be generally of some loss of information, okay, we can say that it's still the probability model does not affect with the observation and the missing values. So MCAR is more restrictive than MAR. The MAR requires only that the MV behave like a random sample of all values in some particular subclasses defined by the observed data. Okay. So if we have the MCAR, it is completely at random. It means all the attributes are missing. And if it is MAR, it requires only that the MV behave like a random sample. So the MV may be in one attribute. Okay? Maybe it is in one or two attributes. Okay. So it has some particular subclasses defined by the observation. That's why the MCR, we call it, this is more restrictive. So it's very a special case of this MAR. When we have the third case, so we have the NMAR. A third case arises when MAR does not apply as the MV depends on both the rest of observed value and the proper value itself. So if you can see this one, it means the observation, the missing value, and the parameter, it affects the probability of the model B. So it means the missing is not at random. So this model is usually called not missing at random, or NMAR, or missing not at random in the literature. The only way to obtain an unbiased estimate is to model the missingness. So we need to model what is the distribution of the missingness, and then what is the probability, and what is the correlation between the other attributes. And this is a very complex task in which we should create a model accounting for the missing data that should be later incorporated to a more complex model used to estimate the MV. So when you have the unbiased estimate, so if you, for example, in some cases you can do with the linear regression, so in some cases you can do with the machine learning approach to estimate, then that kind of thing, it should be incorporated with the complex model or the generated model that you want. So there are many methods in dealing with missing values. So I will explore. So I will go to this detail one by one. Okay. So first, it is about the DNI, do not impute. And next is about we can delete or ignore the missing. We have like two ways, leastwise or pairwise. And we have the substitution, so we can have the global or the concept. And we have the method like LOCF, hot tag, cold tag, and some imputation. So those are the methods for the imputation. So simple approaches to missing data is they usually do not take into account the missingness mechanism, and they blindly perform the operation. It means, yeah, we just remove it, okay, and we just do the operation. We don't care about the missing values. Yeah, that's why the most simple approach is to not impute. Okay? So it means do not change the value. The missing value remain unreplaced. So the TM algorithm, so TM means the data mining algorithm, must use their default value, the default MV strategies if present. So the MV strategies, yeah, you can have like change with min. Okay, maybe this is the default strategy. Change with min or change with mode. Okay, or I don't know the other strategy. An alternative for these learning methods that cannot deal with MP, yeah. Another approach is to convert the MP to a new value or encode them into a numerical value. So such a simplistic method has been shown to lead serious inference problems. For example, okay, I have like this one. I have the data, okay. I have income, and then I have like the age, and then I have the sex, okay. So the person one, person two, so this is missing. Okay. So what happened if it is missing? So I assume that okay, his salary is 999 million. Okay, so I put a very big value to replace this missing value. What happened to this one? Yeah, so this will lead to serious inference problems. Yeah, because we are encoding to a new value. So this new value, if you do not have the definition, then it will have a serious problems. So a very common approach in the specialized literatures, even nowadays, is to apply case deletion. Okay? So just delete it or ignore the missing. Okay? That's the simple way. So all instances with at least one MP are discarded from the data. Okay? Under the assumption that the data is MCAR, yeah, so it leads to unbiased parameter estimate. So it means no problem. Okay, there is no bias with the parameter. But even when the data are MCR, there is a loss in power using this approach. Okay? Yeah, you can have some loss in power. It means you don't have any. Yeah, it's more efficient. Okay, there is a loss in power. It means when you try to analyze, if you just delete the row, then no problem, right? So when we are dealing with the other kind of approaches, for example, the substitution. Okay, so the substitution of the MP for the global most common attribute value for nominal attributes, okay, and the global average value for numerical attributes. So this is the global strategy or the most common strategy. You can use the most common attribute value for nominal and global average value for numerical. Okay. Yeah, in some cases we call it as MC. Okay, most common approach. Okay, so this one is we call it most common. A variant of MC is the concept of most common attribute value for nominal attributes and concept average value for numerical attributes. So we have the C. C is the concept. Okay, what is the concept? So the MV is replaced by the most repeated one if nominal, and is the mean value if it is numerical. But okay, but consider only the instances with the same class as the reference instances. What does it mean? So, for example, if you have the iris data, okay, I assume that you already know all the iris data. Okay, so in the iris data, we have the setosa, okay, and then we have the versicolor, and then we have the virginica. Okay, so we have three kind of flowers, and let's say there is a data, okay, in the sepal length, for example, and the sepal length is missing, and we know that the data is the versicolor. It is the flower of versicolor. Then what will you do to deal with this missing value? Okay, so we can use the mean. Okay. We can use the mean among the versicolor data, and we can replace this with the mean only from the versicolor, not from all those three flowers, but only in the same class. Okay. So this is the same with the nominal data. So if we are dealing with the nominal, maybe we will find the most repeated value in that particular class. But in the iris dataset, we don't have the class. We don't have the categorical data. We don't have the nominal data. Then, yeah, we don't have any example for this one. The drawback for this one is the covariance. The covariance in the imputed data set will be severely altered if the amount of FMV is considerable. It means if the amount of missing value is quite a lot, okay? So if the missing value is quite high, yeah, it can affect the covariance, and when it affects the covariance, of course it will deal with the problem like linear regression, or some of the multiple regression will affect the result. Okay. Deletion methods. So we can just delete all cases with the incomplete data and conduct analysis using only the complete cases. Yeah, it's simple. Okay. And this advantage, we have loss of data if we discard all the incomplete cases. Yeah, some people said it is inefficient because you don't care about the data. Okay. So if you use complete case analysis, then change summary statistics for other variables too. Okay. So this is a mechanism when you are dealing with the deletion methods. So let's say like this one. Okay. I have the three data. Okay, so this is the first data, and then this is the second data, and I have the third data. Okay. So in the first data, you can see there are some NA. Okay. What happens if I delete this data? If I delete this, yeah, then of course I need to delete all the cases, right? If I delete these cases, then I can have only the I can have only this data. How many data that I have here? Now I have the remaining, which is 8 rows, okay, multiplied by 4. Okay, then we have like 32 data are useful for our analysis. And how many data that we are lost? Okay, we have lost like 8 data. Okay, then it means we have 20% loss. Okay, we have 20% among the data that we cannot use for the analysis. Okay. Now let's move to the second data. In the second data, okay, you can see this. This is the missing data. Then what can we do here? Okay, it will be better to eliminate the column, right? So we don't need this column. Just delete those data, and then we can just use the 3 remaining column. In this case, we have the 30 data for our analysis, and we have like 20%, 25% loss. What about this? Okay, it's more complicated, right? We have this one, and this one. If you want to delete based on the columns, so you have only one column for analysis. Of course, it's not good. But if you want to delete based on the row, you will delete 6 rows. Okay, what will you do? If you have this rows deletion, then you will have only 4 rows, and you will have like 16 data, and you have 60% loss. Okay. If you also do this one, the data will be lower. You have only 10 data. Okay, and if you have only one attribute, sometimes it is very difficult to do the analysis. So what can we have? Well, what can we do with this one? Yeah, of course, there should be a way to replace these missing values. Okay, so when we deal with this analysis, we know that if the data is like this one, like missing, at random, we have no idea why this data is missing in this part, why the data is missing in this part. Then it is missing at random, and we need to handle carefully for this kind of missing values. There are other kind of strategies. Okay, the strategies, we call it the leastwise deletion, or as I can explain to you, we have the complete case analysis. Only analyze cases with available data on each variable. So if the cases means the instance. If the instance available for all variables, then you can analyze it. So the advantage is simplicity and comparability across analysis, and this advantage, it reduces the statistical power due to sample size, and we do not use all information, and the estimates may be biased if data not MCAR. So if it is complete at random, so we will delete just one instance. But if the data is like this one, okay, if the data is like this one, of course it is it's missing at random, and this is very tough. So the leastwise deletion often produce unbiased regression slope estimates as long as missingness is not a function of outcome variable. Okay. The other approach, we call it pairwise deletion. The pairwise deletion, it means we want to have the available case analysis. The analysis with all cases in which the variables of interest are present. And we want to have only the variable interest. Okay, so the variable interest means if the variables are, or the attributes is available, okay, then we are treating the other variable which is missing or not. The advantages is we can keep as many cases as possible for its analysis and use all information possible for the analysis. But the disadvantages, we can compare the analysis because a sample is different each time, and the sample size vary for its parameter estimation. sometimes we can obtain nonsense results. So the idea is how we can compute the summary statistics using NI observation, not N. And we can compute the correlation type statistic using complete pairs for both variables. What does it mean like this one? Maybe we can see this. When we use the listwise deletion, yeah, we can just delete this one, and we can delete this one, delete this one, and delete this one. Of course, when you use the listwise deletion, we have very less data. Okay, we have only 1, 2, 3, and 4. So we have 4 data. So in the pairwise deletion, we know that the missing value is the manpower, sales, and this is regarding with the gender. Okay. So we need to check what is our interest. Okay. What is our interest? If our interest is to see whether it is any issue with the manpower and the sales, okay, then yeah, we will just remove this one, and this one. Okay. Then we will remove only 3 instead of 4. Okay. So we have this one, we have also another missing. If we remove this one as well, then we don't have any more data. So the pairwise is just checking what is the important of the interest. If we have the interest of the data is this one, then we can just have 3. Of course, if you say, okay, if I also want to include the gender, yeah, you need to remove this one as well, right? Yeah. So yeah, it depends on what your interest is. Yeah. So yeah, that's the meaning by the pairwise deletion. When we are dealing with this kind of missing values, we can also deal with another strategy, especially if it is related with the numerical, okay, or if it is related with the longitudinal data problems. What does it mean by longitudinal data problems? Longitudinal means you want to see the result or the effect of a study for a long time. So for each individual, NA are replaced by the last observed values of that variable. Then analyze the data if the data were fully observed. And the disadvantage is the covariance structure and distribution change seriously. Okay. So for example, I have one person. Okay. So this is the observation time. 1, 2, 3, 4, 5, 6. Let's say this is the year 1. Okay. Maybe this is in 2010, and then this is in 2011, okay, for example. So you have a very big time frame. Okay. So this is 2012, 2013. So you want to get the value every year, 2014, 2015. But yeah, it's very difficult to maintain this kind of process. Then yeah, you can see there are some missing values here. Okay. So you maybe after 3 years, the person do not want to continue. But yeah, the second person, he still continue, okay, until the 6 years. The third person, he doesn't want to continue, or maybe there are some issues, so you cannot get the data. Okay. Then how can you handle this? Yeah, there's one strategy, we call it last observation carried forward. So the first data, we can just check what is the previous value and we replace it with the last observation. And then the next value, the next missing value, we also use the last observation. And then the next one, we also use the last observation. By using this one, yeah, of course, yeah, this is easy, but the disadvantage is the covariance structure and the distribution will change seriously. Yeah, we have the case or subject number 3. Yeah, we can also do the same. This one, the 3.5 will replace the next one, and this NR will be replaced also with the 3.5. This is what we call as the last observation carried forward. There is another strategy. We call it hot tech and cold tech. Okay, hot tech means sorry. We replace its missing value, or we call it the donor, with a random draw from a subsample of the respondent that scored similarly on a data set of matching variables. So I give one example like this one. Okay, I'm not sure if it is suitable with the example, but let's say. Suppose that a patient survey was conducted in 2 hospitals. So we have like hospital A and hospital B. And that five people from hospital A failed to respond to an item of the survey. So when there are 5 people who cannot respond, and sampling 5 values from the respondents who did respond to that item at hospital A, and substituting this value for the missing observation in example. Yeah, so this is the hot tech imputation. So we got, like say, I have like P1, P2, P3, P4, P5. So there's an item like maybe weight. Yeah. So the weight is missing in this 5%. So you have actually already P6 until P100. Yeah. So how can we do this one? Let's say this is the patient in the hospital A. Okay. And this is the example in the hospital A. And you have another data in hospital B, but you don't use the hospital B for this one, because all this one I assume that the patient are similar between this missing value and the existing data. So in this case, I'm just using the weight and I do the sampling. So the sampling, maybe I just select 1, 2, 3, 4, 5. Yeah, just do sampling. And then I put this value into this, and then I put this value into this, I put the value into this, I put this value into this, and I put this value here. Yeah, this is hot tech. Okay, so with the same example in the particular observation, I would like to put it into the missing values. Advantages, it generates a complete data set. Of course, you have no missing value in these 5 people. But the disadvantages, not well suited for estimating measures for association. Okay, if you are familiar with association rules, okay, this kind of method will not be good for the association rules. If it is only about the weight, maybe that's okay. Yeah, but when you are doing with the nominal data, it will be biased. Okay, if it is not nominal, if it is a nominal data, okay, it will be biased. Product substantially biased estimates of correlation and regression coefficient. Yeah, if it is numerical, yeah, if there are so many data with this kind of missing, and you replace with this the same value with the sample, of course, it will also give you bias. Cold tech. So we are making use of a fixed set of values which cover all of the data items. So suppose, for example, that a patient questionnaire was administered in a hospital and that 5 people failed to respond to an item. Okay, so the same. Okay, the same with this one. 5 people failed to respond to one item. So substituting response from a similar item on survey conducted previously will be example of cold text imputation. So it means I do not care about whether it is in the hospital A or in the hospital B. So I can select randomly, yeah, and then I put here. Okay, so hot tech means if it is uh, in the same population, or they are in the same institution, then we can do. But cold tech, yeah, you don't care whether it is in the same institution or it is in the same population, but at least you know that you can have another similar item on any survey that you already conducted previously. Okay, what we got that as cold tech. So yeah, there are some other imputation methods. Okay? Before I continue to the other imputation method, I think I will stop and I will continue with another video.